bunch of votes for average winnings in this game. We got 0, we got 1, negative. Now we've changed our vote to negative. We've changed our vote to negative. Oh goodness. Okay. So here, rather than just go straight to technology, which I do want to go to, of course, let's crank this one out manually first to show how the average is built over the long run. If that's okay with you guys. I think that's going to help us to see. Because now that we've established over 6,000 trials, let's see what happens over those 6,000 trials. At least, you know, assuming that's a good representation. So I want to go with average winnings. And what Andrea is telling me is I should put winnings in parentheses. Spoken like a true actuary. Excellent. So, do you remember how to you remember the calculation for a weighted average? We haven't done one by hand in a long time. It's been a while. I think the GPA calculation we did last by hand. Remember how to calculate a weighted average manually without using, I mean, it's one of our stats L1, L2. You know that. Remember how to do it without using technology? You can say no. It's totally fine to say no. It's been 3 weeks. Totally fine. So, what you would do was you take each one of your outcomes and multiply it by its frequency.
Right.
So you take each data point, multiply it by its frequency, and then you divide by how many frequencies there were. That was the old formula from, this is going back about 4 weeks. Back about 4 weeks. Let's just change it to fit us now, because now we've got new situations. I still want to call X X. But what are we now calling the frequencies?
P of X.
P of X's. Yes, absolutely. So take each X and multiply it by its probability, which is essentially the same thing as a frequency. It's a relative frequency. How often did it happen over a certain number of trials? Now here's where it gets totally badass. Some of the frequencies would be the same as some of the probabilities, which is what? 1, which means that's all we have to do right there, calculating-wise. Each payout times its probability, plus the payout times the probability, plus the payout times the probability. It's like a dance. And just add them all together, and that's your average. It's wonderful, huh? Watch. Let's do it together. So it might seem scary because it's a formula. Let's get the formula out. Let's get the formula out. First payout, -$1, right? First payout, -$1 times the probability, 57.04%. At this point yesterday, a student stopped me and said, "Dude, why would anybody play this game?" And I said, "Wait a minute. I mean, because her point was that you're losing 57% of the time, right?" And this goes back to what you guys were saying about, you know, Vegas making money. And I said, psychometrically, they've got you with the next one. Watch this. Then, 35.12% of the time, you don't win anything. But you got to remember what not winning anything means. You put $1 down to play. What did they just do? Give it back. It cost you $1, but you profit 0. That means they handed you $1 back. Somebody's handing you money, right? I'm trying to think of an example where somebody hands you money. Somebody tips you. I used to be a bartender. I get tips for doing my bartending, right? Somebody hands me $5 in tip, and I just go, "Man, that's $5 in tip." What I don't say to myself is, "Well, I owed $500 for rent today, now I owe $495." I don't think of it like that right at that moment. Somebody's handing me money, I'm like, "Sweet money." So then I want to bartend better, right? Get more tips. So the same thing. Somebody hands you money back. You're not viewing it as an erasure of your debt. You're viewing it as somebody's giving me money. I want to keep playing. And how often does that happen? Roughly 1 out of every 3 times. That's a lot of money going back to you that really isn't giving you profit, but is giving money in your hand. You see what I'm getting at? See the problem? So right now, at this point, you have accounted for 57% plus 35%. What is that? 92% of the games? And you're losing money right now. 92% of the time you're losing money. But in 1/3 of all the trials, you're getting money handed back to you. But on average, you're still losing money. It's a genius game. It's a genius game. Because you feel like you're getting something back, but you're still losing money. But now, they start, back to Linda's question, now they start padding it, right? They give you $1 here. But they give you $1 7.35% of the time. Yes? Mm-hmm. But now you're less negative. Up till now, you're down 57 cents. You're down 57 cents. you're still down 57 cents. You just got about 7 cents back. Now you're about negative 50. You're about negative 50 cents now, yeah? But now, the big win. Here comes the big win. That's going to get us out of the woods, isn't it? Except, the problem that it only happens that often. You're right, 5 out of every 1,000 trials. 1 out of 200. So what does that come to monetarily? Well, whatever it comes to monetarily, it doesn't offset the negative from before. What does this whole thing work out to be, friends? What does that whole thing combine to be?
$100. $100%?
No, it's gonna be minus.
It's a monetary amount,
Two.
and it is most definitely negative. What? Add that up. Add that up. Yeah, add that up. Because you got to know this. You got to know this. This tells you how much money you're going to lose.
-1.
Tells you how long you can play. I'm going to play every 5 minutes. Tells you how long you can play in Vegas. So you got to go somewhere else. Make more money. So you go to Vegas again. Yeah, what do you get? Negative 0.4. Keep going, keep going. Negative 0.451, how's that sound? What does that mean? Interpret that for me. Good, nobody guessed negative 45 cents. Nobody guessed. You guessed a 0, you guessed 1, you guessed 2, nobody guessed negative 45. First of all, you can't lose 45 cents on a game, can you?
No.
That's not a payout. But what can you do? With
Spend more money.
well, I'm sorry. to bring in the negative 45, you can't actually lose 45 cents in one game. But over a period of time, you can average a loss of 45 cents per game. You're either going to lose $1, gain $1, break even, or gain 9. But the weighted average of those 4 outcomes weights out to negative 45 cents. So in other words, instead of even playing the game and wasting everybody's time, just walk up to the table with 45 cents, put it on the table, and walk away. Because that's the same as playing the game. Tom, go ahead.
Or it just says not entertaining.
It's not good.
It's maybe entertainment for
That's how you have to view it. You see, many students tell me, like, Rule, now I can't go to Vegas. I'm like, no, time out, time out. I'm not saying don't go to Vegas. I'm saying view it as entertainment. That is the price tag for going and playing the game. It's going to cost you 45 cents to play the game. Is that worthwhile? I think so. It's fun, right? You're in Vegas, it's velour, it's carpeted, people smoking indoors. It's fun, I guess. But it's your entertainment, right? So in other words, I gave Gail $1, and she paid back 55 cents, and she kept 45. If the exchange I had was worth 45 cents, then it's entertainment. How many times have I seen Life of Pi in the movie theater? When it was in the movie theater, I went 5 times to watch Life of Pi. Over $100 spent on tickets to watch a movie. Plus, we bought popcorn for $8. Why? Because it was worth it for me to go to see that movie on a screen that big. It was worth it for me. It's entertainment. View it as such. It's okay. It's totally fine. Nothing wrong with it. Is that fair? Is that believable? You guys buy that? Good. Just realize you're going to lose money. Please, just realize that. That's what I want to teach you guys. There's an old cartoon I saw. I can't find it anymore. If I can find it, I'm going to print it and put it on my door. You've seen the sign, "Welcome to beautiful Las Vegas"? Or the wonderful Las Vegas. As you drive into, if you've never been to Vegas, there's a sign,
Yeah.
"Welcome to beautiful Las Vegas."
Yeah.
There's a great cartoon that was made up where somebody tacked a sign under that said, "Generously paid for by people that are bad at math." You have to realize how they can keep their lights on all the time. You're in the middle of a friggin' desert. You're nowhere near natural resources. Yes, they've got the Bellagio fountains. You've got lights on all the time. They're giving you free drinks to play their games. How are they doing that? One at a time. They are doing that to people. If you can realize that, it's way more fun. It's way more fun if you can realize that. That make sense? You guys buy that? Where's on your mind, Aaron? Go!
Well, I wonder if there was any calculation that went into you win $9. Because, I mean, in order to break even, you'd have to win 110 with the jackpot.
Oh, you've already solved the quiz for them for next week. Good for you. Don't worry, you'll get to that. If you do the quiz for next week, you know the answer to it. Well done, sir. Good for you. No, don't be sorry. It's a great thing. You still have to show me why it works. So what Eric just figured out is, and this goes back to Linda's question. Remember the question you asked 15 minutes ago? So what Eric is asking is, why 10-to-1 payouts on the big one,
I
right?
mean, they could make you win $50 and they'd still be making money, so why 9?
You've got a career path right for you, brother. You go to Vegas, you set the probabilities with the payouts. He's realized, he has run the numbers on this distribution, and he messed with this number until the average came out to be what?
0.
0. Once the average is 0, that means the player doesn't lose any money and the casino doesn't lose any money, and it's called a fair game. No game in Vegas is fair. Couldn't be, right? They bankrupt themselves if it was fair. So if the Vegas then knows the payout for a fair game is $110 on 3 5s, they set, good, we're starting to think about it now, good. We set this at 10-to-1 payouts, and then every once in a while, they say, hey, Frank, Chuck-a-Luck's not getting a whole lot of play. Let's triple the payout to 30-to-1. Right? Let's triple the payout to 30-to-1. So now you're going to be profiting 29 instead of 9 on every dollar. What do people do? They flock to Chuck-a-Luck tables, right? They flock to Chuck-a-Luck tables. Why? Because the payout's 30-to-1 instead of 10-to-1.
Right.
But guess what Vegas is still doing? Making money on the not as much. It won't be 45 cents anymore. It'll be
Negative.
something like 37 versus 45, but they're still making money off of you. And they might even be making more because more people are playing. The psychometric, the behavior of casino odds setters is phenomenal. I mean, they're geniuses. They really are. Evil geniuses, we could view. But it's absolute genius. It's like, how many people, they probably even know, I would not be surprised if they knew down to the person what one increase in dollar payout would do to the population of those playing the game. I wouldn't be surprised if there's a quadratic relationship that somehow maxed out on 10-to-1 for starters. I wouldn't be surprised. I would hope there would be something like that. It's a pretty, dude, you guys are qualified now. You guys are qualified to do that job now. Shit. Change your major. All of you, change your major. You'd be great at this. I believe in Vegas.
Yeah.
Please, Linda! Yeah, no. Go ahead, Linda.
Is there the values that the computer generated for
Yes, ma'am.
0.57, is there a longhand way, I mean, kind of what we did?
Yes,
with
ma'am.
probability?
Yes, ma'am. Let me give you a glimpse because we're getting to that next week.
Oh.
It's called the binomial distribution. We did the one by hand, 1 and 216. Remember that one? 1 and 216 was pretty easy to figure out.
What would be, like 216 times 215 or something?
They're 3 independent dice, so there's no need to go 216, 215. It's just 216. It's 6, 6, and 6. 6 times 6 times 6, 216. Fair? To get the other probabilities, you can do other calculations. For example, the chance of not getting any 5s at all is 125 out of 216. And the reason is, if you don't want to get any 5s, that means you have to, on every one of the dice, either see a 1, 2, 3, 4, or 6. So there's 5 ways for the first die to fall, and then 5 ways for the next, and then 5 ways for the last. 5 times 5 times 5 is 125 out of 216, which ends up being damn close to 57%, which we calculated in our Excel spreadsheet. The other ones are more interesting. The other 2 are more interesting. So what's the chance of getting 1 5 and 2 that aren't 5? Okay? So one of the dice has to be the 5, correct?
Right.
So that one has 1 choice. It has to be a 5. The other 2 have to be 5 choices, 1, 2, 3, 4, or 6. 1 times 5 is 25. But it gets interesting because that 1 5 die could be any one of 3. So you've got to triple that to make it 75 out of 216. Now this is where it starts, you're starting to like, oh God, it's Thursday, would you stop talking about this? This is why I have a whole section devoted to just that distribution, because it's worth looking at more microscopically. I start with this here, and then we build up to that next week. My chicken flock, actually, we'll put you with my chicken flock. Fun way of looking at it. Is that fair, Linda? Yes, there is a way of calculating it. There usually are ways of calculating things via my manual calculation. It's just that generally, once we've done it once or twice, it's like, let's just let technology run with it. Cool? Other questions? Those are great questions. Yes. So on average, you're losing 45 cents. It's the price of admission for playing the game. So Vegas knows this. They see somebody walking up to a table, they go, 45 cents. Right? 45 cents. Holy crap, 10 people. Oh, we're happy. That's how they make their revenue. I mean, they got to pay for all those drinks and all those salaries and everything else, all those lights. All right, now, last thing for today. Let's gamble with my life, actually. Speaking of which, here, grab one of these. You can work together, you can work independently, whatever you want to do. I'm going to grab one for myself. This is applying what you just learned to a life insurance policy. I'm going to give you a backstory on this one because there's a reason you're doing this quiz. I always like to think